What's up everyone, and welcome back once again. So in this video we are going to be doing something quite different from what I've been doing earlier. So in this video we're going to be talking about converting unstructured data. So this will be like a raw text file to structured data, and then after that we are going to be storing this in a Neo4j graph database. So there's a couple of things that we are going to be tackling in this video. And some of the tools that you're going to be using is Ollama, LangChain, and the Neo4j graph database. So where you're going to be storing that information. So actually in this walkthrough, our goal actually, as I have specified, is actually converting structured data. This can be something like financial text or any type of textual data. So when you're talking of financial, it can be something like earnings report. So you're going to convert such type of data into a structured knowledge graph. And this one, we're going to be using a Neo4j as our database. So let's start with the basics. I think up to now, you have come to an understanding about Neo4j. And when we are talking of Neo4j, two things that come into mind is about the entities and relationships. So with Neo4j, we're able to create entities, and we're able to ensure or connect these entities based on their relationships. Okay. So what is it when we're talking about entities? So entities, these are the main objects or things that are being mentioned within your text. So considering a financial text data, we can be talking about companies or people or products or even events. So those are you can call those as the, in literature language, if I'm not wrong, those are the main objects, the nouns, okay? So those are the companies, people, products, events, the main things that are being discussed within the text, okay? So once we are able to separate the main entities within the text, then we need to be linking those entities together. So now that's where the relationships actually comes in, okay? So we're able to describe how these entities are actually connected. So for example, a company can employ someone, okay? Or a company can be located in certain states, certain country, okay? So a company can employ someone, or this company can be producing something like a product, something like that, okay? Or this company can be offering a service. So you can see a company offering service, company producing this type of product, or a company is employing someone. So we can see how those entities are, we're able to link the entities to their and define some sort of a relationship between them. Okay. So why do we essentially extract this? So because in most real world, information is located in raw text. Sometimes it's very hard to find the structured data. And so it's upon us to actually turn this into structured form. And once we do this, we're able to analyze, we're able to visualize and reason over this using, now this is where the Neo4j comes in, because normal SQL databases cannot actually help us analyze such type of information. So having a graph database will enable us to actually separate the entities, define the relationships, and actually visualize this using a graph database. So how are we going to extract this? We're going to use large language models. Of course, there are different techniques that you can actually use to extract the entities and link those relationships. But one of the most, let's say the easier way you can use is use the large language models. Essentially, we're just using the reasoning capabilities of these large language models, and then we are going to pass some text onto them, and they're going to help us to actually extract those. So in this case, we're going to use a LangChain. So LangChain and Ollama. So what Ollama enables us to do is that we are able to do this locally. So I'll show you how. So we are going to use LangChain and Ollama to process the text and output. Once we process this text, we're going to output a structured JSON file, and this will contain both the entities and how these entities are actually related to each other. So essentially, we are going to pass some text and then you'll see that. Then now from that text, we're able to extract the graph components. Graph components, those will be the nodes and the relationships. And after you have done that, we're going to load them into a Neo4j AuraDB database. Thanks Neo4j for that. So we are just going to use the free tier for that, so that we're able to see how we actually manage the entire process. Then after that, essentially we are going to visually explore the knowledge graph. Okay? So that is in a nutshell what we're going to be covering under this session. So let's get started. Okay? So I think you have a slight clue or an idea of what we're going to be doing. And so with that, let's get started. So with the Ollama, essentially I said with Ollama we're able to do this locally. So with Ollama we're able to actually download these large language models into your local workstation. And then from there, we're going to be able to actually utilize that. So you can just go to Ollama, just search for Ollama, then make sure you can just sign in. Then once you sign in, you're able to download. So as for me, I've already downloaded Ollama. So Ollama will enable you to actually work with these large language models locally. So you have to download it first. So once you download it, and it's just a simple process, download and install it. And once you're done with that, then you can go to the models. So with the models, there are different types of models that we're going to use. So we have DeepSeek, we have Llama 3.3, we have the Quen model and all that. So for my case, I've actually downloaded some of these models. So let me, so Ollama help, so that I can just find these commands to use. So let me list all the models that I have downloaded. So Ollama list. So you can see I have two models. I have the DeepSeek R1 and the Quen 3 model. So you can download several models. But also when you are downloading these models, you need to consider something. So for my case, I downloaded this one, size which is about 1.1 GB, just because whatever desktop I'm using can only has a maximum or amount of space. So I cannot work with the 404 GB space for that. But if you want better performance and all that, it's better you go for the bigger models. I think this one will get better performance for that. But because this is just an illustration of how you can actually actualize this process, I'll just use the DeepSeek. I think I'll use the DeepSeek, this one. So once you download Ollama, you have installed that, then you have in the models. So you can just click on let's say I'll use this model. So I'll just click on this, and then make sure you copy this link. Once you copy this is the command that you're actually going to use to download this model. So once I paste it on your terminal, so I'm just using PowerShell. You can use command prompt, just the same. So Ollama run DeepSeek this and this. So once you enter this or execute this command, it will actually download the model that you are seeking. So for my case, I don't want to download this fresh because I've already done it. I'm not going to do it again. So you are free to use any type of model, that you want. So you can see we have several models: Gamma 2, Quen, Llama, okay, Dolphin, BGE, okay, the bilingual model. So there are very models that you can actually use under this. But for my case, I'm just going to use a DeepSeek R1. Okay. So once you have done that, you have your DeepSeek. You can see you have the model. Then now it's time to start the actual process itself. So I'll use PyCharm for that. So this is PyCharm, and I'm going to use this to actually show you how we can try to so I'm going to use this one so that we can actually So the first thing, once you have set up everything, is to make sure you have the necessary dependencies. So for this one, I'm installing and upgrading. I'm using LangChain, LangChain community, Neo4j, Open. I don't think I'll use OpenAI. Then IPY kernel, Python.env, because you need the username from Neo4j, and also LangChain Ollama for that purpose. Okay, so make sure you have this installed. So I'll just make sure I'll install this, and so once this is running, we can now start the process. So I've just created a new folder, graph rag, and under this one I have this file, local rag. Let me just rename this. This one is the local rag rename. So you can say it's supposed to be local. Just name it to local rag. So make sure you have all these in place. Then one thing that I'll have to add, I'll have to add a piece of text. So let me have to add text that you're going to use. So this is just a simple text that I'm going to, let me first look for it. So I have anyway, when we get there to that point, that's when I'll show you. So so at first, so we have installed the necessary dependencies. The first thing that we need to do is actually see how we can actually extract the entities from the text that you're using. Okay? So extract the text from a file. So how are we going to extract this text? Don't need this. So import then put JSON. Then another thing that we're going to do now from LangChain. LangChain Ollama. I'm going to use LangChain Ollama. We're going to import, I think it's Ollama LLM. Then so we are going to create something like a prompt. So this prompt will actually enable us to extract that. So from here, let's say from LangChain prompt, import the prompt template. Then another thing that I'll want from typing, I'm going to import list dictionary. Okay, I think this for the moment this is what we can use as for now. So the first step that we are going to do is actually load the model and the prompt. Okay, so load the model. So the model that you're going to use is the DeepSeek. Okay, so LLM, I'll use Ollama, supposed to be Ollama LLM. Then now with the Ollama LLM, so what you're going to specify is that's the model. So if you are using, let's say if you're not using it locally, maybe I should do another video for that. If you're not using it locally, then you have to provide the endpoint as well as the API key. So for example, you're using Together API that provides you API keys for these models, then this is how you can actually pass them here. So the endpoint for that as well as the API key for that, so that you're able to link the model. But for this one, we have downloaded the model locally. So we need to use that model. So for the local, if you're going to use that one, then I'll have to specify the model. So that is the model. For my case, the model for me, I'll use DeepSeek. I'll use DeepSeek as my model. So I'll just copy this, make sure I paste it here. So model DeepSeek. Model DeepSeek. Then another thing that is about the temperatures, because I want to extract the entities accurately, then I have to use temperature closer to 0. So in essence, I just use 0 so that I make sure I'm able to import those entities. I'm able to extract the entities without a lot of variability. Okay. So then from that, I prepared the prompt template. So I'll just, it's quite lengthy. So I just don't want to type all this because it might take it into our time. So this is my prompt template. And under prompt template, so the input variable is a text. So then the template is this. So we are basically telling our model that you're an expert system that extracts knowledge graphs elements from complex text. Let me just use text. Then your task that you are given is actually to extract first the entities. These are the organizations, people, locations, products, funds, sectors, and all that. And the relationships include types like employees, acquired, partnered with. So these are some of the, I think, something to do with the few short learning. So we are giving our model some sort of an example. Okay, so we are telling our model, okay, these are some of the entities. If you find them, note them as your entities, and these are some of the this is how some of the relationships actually occur within a given text. Okay, so then once you extract these entities, we want you to return some sort of a valid JSON file within this format where you have your entities, and here when you have your relationships. Okay, then the text to analyze will be in a form of a text. So we'll pass you a text, and we want you to actually extract the entities as we have said here, and also the relationship accompanied from that. So when we are doing this, when you're doing this, we'll want to do some preprocessing steps on the text that you're going to extract. So let's do some chunking. So let's do some chunking on that specific text. So I'll just use a function. So let's say smart chunk, and I'll specify, let me, so the text is actually a string, so it's a string. Then the maximum tokens, maximum words, use words. So this one will be type hint. So let's say we are using 300. Then what we are going to generate is a list of strings. And so the first one we are going to split by selection, by section headers, not selection, section. By section headers and paragraphs. So I think if you understand a little bit of NLP and what have you, so you understand we are using re. So re is the I think this is where we're supposed to use the regex. So import regex. So we're importing that regex. So splitting sections according to this. So I'll have to actually modify this. I'll have to modify this a little bit. So this is the one that we're using. Then we are creating an chunks as an empty string. Then for the chunks again, so just yes current chunk. Then you can just use supposed to be then I'll just do away with this. Okay. Then for section, in sections, so we're saying words, so that is the section we're going to split. We're going to split that word section there. So then we specify if the length, so that's the length of current chunk, the length of that current chunk, split first, dot split, then plus the length of the words. So this one should be, I think should be less than or equal to, yeah, less than or equal to the maximum words. Then the current, I'll just do away with this one, then say plus the section, then or else then we just append those chunks. So and then here we need to strip. In this stripping, then after that chunk selection, I don't want to go to the new line. I think by doing that, so for section in sections, words section split, if the length of the current split plus this one is less than or equal to the maximum words, then the current chunk plus that section, or else we append current chunk strip. Yeah. So if current chunk, this one is okay. This one, yeah. So if current chunk, then just do the chunks dot append. So I think we are merging those together. So this will be current chunk split. Then we are going to return the chunks. I think this one is okay. Yep. This is not defined. This is not defined. This is not defined. So should we should import import the regex and also from typing import list. I think that one is, if I'm not wrong, that is what is needed. Yep, I think that one is okay. So make sure you run your prompt template, and after that this one is okay. L3 is running. Then the chunking technique. So once we are done with the chunking, we need to move to the extraction and cleaning. So you can just this is just the necessary steps that we can use so that to make sure that that process is well. So extract, I think I just use knowledge graphs. Then text chunk. I think this will be strings. Then the output from this will actually be dictionaries. So I can also import that one from typing. From typing, import dictionary. That this one. Then I'll try to use let me use a try except block here, so that in case of any errors we're able to capture those errors. So then how are we extraction and cleaning. So we first need to use the prompt template. So prompt template. Then use that one on the LLM, and then the results that you're getting from this. So that is the result, or what you can say, chain.invoke. So what are we doing here? So we are actually now the text. So this one is like we are chaining those processes together using LangChain. Now how those processes are going to be carried out. So that's the text, and then this will be the text chunk. Then this one, text chunks. Then this one we are saving it as, let's say, result. Yep. I think that one is okay. So and JSON string here. So this one re.search. Here we can specify some this JSON. Then we can return the JSON loads. So yep, I think that one is okay. Then we can just close this with an exception. Then print error. So if there is an error, what we can do, we can say error extracting from chunks. So then you can add another one. Then you can just say row so that /n results. Then we can say return entities and the list the relationships. Okay. So I think this one is let's make sure we are doing okay. Supposed to be results. Yeah, extraction and cleaning. So once we have extracted those chunks, then we can do some merging. So merging. Let me just copy. I think I had already done this, so I'll just copy this one here. So this one is where we are doing some merging. So with the function, so the function, this function or the method that we're doing here takes in a list of knowledge graph dictionaries and merges them into a single knowledge graph. Therefore, we're doing this we can say this one is a process like post-processing. Yeah, post-processing, so that we're able to eliminate removing duplicates and all that. So we don't want to create nodes and relationships that are duplicated. Okay, so we need to do some post-processing steps to ensure that we're able to achieve that type of clean nodes and relationships. Okay, so the first one. So this is it takes in the list of knowledge graphs. So KG list, where each graph is a dictionary. So we have specified it's a dictionary. Then the output for this one will be a single dictionary with merged entities. So it's a single dictionary with merged entities and relationships. Okay. Then so this one we're using a set. So this set actually tracks the unique entities to prevent duplication. Then we are going to store those merged list. So store those merged as a list of unique entities. I think also collects all the relationships and also doing the same things on that. Then from this one, we're just using something like a for loop. So this for loop will actually iterate through each knowledge graph provided entities in a list, in a given list. Then from there, for each entities in the knowledge graph, we're going to create a unique key. Where is it? We're going to create a unique key using the type and name. So we're going to create a unique key. These all steps just to prevent those having duplicates. So unique key and list for that. And if the key hasn't been seen, we're going to just add an entity to all entities. So we are going to add, if it has not been seen, we're going to add into the main entities. So we're going to do this to avoid the duplicates. So this is the merging the preprocessing steps. So essentially, we're just creating functions. Then these functions, we are going to be using them in the final once we input or we load the text. So this is where we now can start now loading the text. So let's load the text. So how are we loading the text? So load the text. This is how we load all the text. So load the input text. So we need to earnings report.txt. So we have a text like this. So let me first load that text so that we're able to see that. So copy. So I think now we should be having, now we have the earnings report.txt. But I'll change this name. This one is, I don't think our text is earnings report. I think it's money laundering scheme. So our text, okay, it's not an earning. So in March 2025, the Financial Crimes Enforcement, in collaboration with the Interpol, uncovered a sophisticated internal money laundering ring orchestrated by Orion's Strategic Holdings, a private firm headquartered in Zurich, Switzerland, with satellite offices in Dubai, Singapore, and Cayman Islands. So it's talking about money laundering. So I'll just copy this and change this from earnings report to let's say money laundering. Okay, then I just refactor that. Okay, so that is the text that we are going to be passing so that we're able to extract those entities. Okay, so we are loading the input text. So the input text is the money laundering.txt. So that is the text that we are going to use. And then we are going to chunk. Step A is about chunking of the text. So I remember we use the function smart chunk. So this is the function that we are now calling. So we're just calling this smart chunk function, and then we pass in the full text. So we pass in the full text so that we're able to chunk that. And once we have done the chunking, the second process is about processing all the chunks. So we are going to store all our chunks in all knowledge graph parts. So for I chunks in enumerate, so enumerate function, then we pass in the chunks. This one here. So we pass in the chunks. Then here we are going to extract the entities and the relationships. Once we have done that, we are going to append those into all knowledge graph parts. Okay. Then this step C is about merging all those parts into a single file. So we are using the function merge and knowledge graph parts. So that's the function that we're using here. So those are the post-preprocessing steps that we applied. So that's we're going to apply to this point here. Then once you're done with that, you're going to dump that file. So I can just use that name, LangChain final file. Then once we are done with that, we can print the extracted entities here, okay, to see how about the entities about them. Okay, so we can run this, but this one might take some time. I'll just extract this. So we have not extract. So we did not run this cell. That's why we're getting that problem. So, but anyway, I'll just run everything from the start. Then I will be patient to wait until this process actually completes. So I'll just run cell, run all. I'll just run everything from the start so that we're able to run this. So while everything is running, we can, once this is done, we can actually print the top 5 entities from both. So let's we'll print those entities. So I'll just say /n. So top. So just say top entities. We're going to print those top entities so that we're able to see how that process actually was done. And then you can say, let's use a for loop here. Okay, so once we execute that, you can see we're able to extract some entities and the relationships. So this is about how the model was actually trying to learn about how to extract those entities and all that. So it's about the thinking process of the model itself. So it's applying that the concept of chain of thought. So you can see how the model was actually trying to reason out when reading through the text, so that you're able to extract the required entities and the required relationships. So this is all about the model. So once that was done, it was now able to extract the entities. These are the entities that the model was actually able to extract. Aura's capital group, Tornado Shield, blockchain. Then from there, some of the relationships that it was able to extract. So finally, after going all through that, these are the entities. These are the entities. You can see entities as well as the entity technology, Tornado Shield protocol, then blockchain analytics farm, chain Visa. So you can see the different entities that it was able to actually extract from that text. So once it did extract that, we can print the top entities as well as the top relationships. So in terms of entities, these are the top entities that we're able to extract from the text. The Aura's capital group, Orion Strategic Holdings, Zurich, which is in Switzerland. We have Dubai, UAE, Singapore. These are the different types of locations. So what about the relationships that the LLM was able to extract? Okay, so you can see that when you're looking at the top relationships, Aura's capital group employs Alexander Volkov. So you can see now able to extract the entity, which is the Aura's capital group. Then we have this person, Alexander Volkov. So how is Alexander Volkov actually related to Aura's capital group? That is where we define that type of relationship. And when the model was able to pass through the text, this is the type of relationship that it was actually able to obtain. So you see that Aura's capital group actually employs Alexander Volkov. Again, Aura's capital group partnered with Andromeda Resources, maybe to perform some service or something like that. Then you can see the different relationships that you are getting from there, from that text. So once you have identified the relationships, you have the nodes and how they're relating with each other. Now it's time for us to actually build the knowledge graph. Okay, so you have to first use from Neo4j import the graph database. Then because you're going to use the JSON file, so you need to have a JSON.env because you're going to you need to set your Neo4j URI, your username, as well as the password. So I'm using the .env file. So make sure you create your .env file and pass in these details. Okay, so the Neo4j URI, the Neo4j username, as well as the Neo4j password. These are the logins that will be given to you once you sign up for Neo4j and actually create an instance of the Neo4j. I think they have a free tier. Then from the free tier, you're able to get the URI, the username, and the password. So I've just placed those in my .env. So from there, I'm able to actually extract that using the get that file from the .env file. Okay. Then we need the graph database so that we establish that connection. So you can see here we are connection initialized. Then we need to verify connection to see if it's actually going to work. So we are testing for that connection to see if that one is okay. Then we create a graph. We create the graph. So remember, with the graph, we have the different entities and we have the different relationships. So we need to make sure that we're creating the graph with these entities and these relationships. Okay. So we create that entities and then with the driver session. So we are able to create the matches. I think this one is just we delete if there's anything in the graph. Then we create the nodes that are required in our graph. Then once we create the nodes, then because these nodes need to they're somehow related. Okay, so we create the relationship for that. Okay, then we close that relationship. Then we load the data. So here we are loading the data or as KG final JSON. I think it's this one here. So this one is the data that you're actually loading to a Neo4j. And once we load that data, then now we are going to infer missing source target types, maybe entity lookup. This one, let be, just give me a minute. So, okay, with this one, we are actually creating a name and type mapping for all the entities and injects the type into each relationship. Okay, so I think this one is the reason we're using that. Then from there, we can connect with our graph database and actually populate that one. So once we run this one, you'll see that we're able to connect and actually connect. And so connecting to the Neo4j AuraDB, then connection was initialized, then connection was successful. So we are populating the graphs, and after we populated the graph, you can see that our graph loaded with 8 entities and 7 relationships. Let me see if you can see that. Okay. So this is the graph that we actually came up with. So this is our graph. You can just zoom it. You can see we have the graph. So the first thing that you can see, we have the this is the this is the Orion strategic holdings and the Aura's capital group. So you can see we had 2 entities. So we had 2 entities. I'm not wrong. We had 2 entities. So the different locations. So in terms of capital group and the Orion strategic holding, so that is what has been captured. So Orion capital group and that. So this one here, Zurich Orion capital group. Then from here you can see we have the different locations. That is the Zurich. So you have Dubai, UAE, Singapore, DR Congo, Panama, and all that. Okay. So I think we are able to capture the entities plus the location, but I'm not seeing the relationship. So maybe when it comes to the next session, I'll try to sort this problem out so that we have the entities and the relationships. Then I'll just update you on this. But at the moment now, I think you have a rough way on how we can actually move from unstructured data text into extracting the nodes and the relationship on that text. Then from there, we are able to come up with a knowledge graph. Okay, so essentially, I think by now that is what we were able to achieve. So we were able to actually move from unstructured data into structured data. We were able to extract the entities. We were able to infer the relationships. And once we did that, we were able to load this into our Neo4j database. So what I'm going to do next is try to recreate so that we're able to form these relationships. And also, once we form these relationships, we're able to query more our results so that we're able to even understand more from the relationships that were actually created from here. So I think that's it for today. The next one, we are going to now delve more into Cypher query language, try to understand it more, try to query our data that is already stored in the Neo4j, and see what type of relationships that we can even form from this data. So that's it from my side today. Until next time, I'll see you.